Hey everyone, welcome to Ghost Python Academy. In today's tutorial, we're diving deep into while loops, a powerful tool for repeating tasks in Python. If you've ever wanted to run a block of code over and over until something changes, this is how you do it. Now, let's imagine a simple counter. You set a starting value, and the loop keeps running as long as that value is less than or equal to 5. Each time the loop runs, the value increases by 1, and you print the current number. The loop stops automatically when the number grows beyond 5. This kind of logic is great when you want something to repeat a certain number of times, but you don't want to use a for loop, maybe because the increment or exit condition is a little more dynamic. Next, let's say we want the user to enter their age, but we want to make sure the input is a positive number. You start by assuming the input is invalid. Then, inside the loop, you ask for the user's age. If it's less than 0, you show a message and ask again. This repeats until they enter a proper, positive number. When they finally do, the loop ends, and you thank them. This kind of pattern is perfect for input validation. It keeps asking until you get something useful. In this case, after rejecting -5, it accepts 24 and displays it. Moving on, let's talk about loops that don't rely on a fixed number of repetitions. These are often called open-ended loops. A great example is when you're waiting for a specific answer, like a secret code. The loop starts with while true, meaning it runs forever unless we tell it to stop manually. Inside the loop, we ask the user for input. If they type the right code, we use a special keyword, break, to exit the loop. If not, we print a message and try again. This is a perfect setup for things like login prompts, pin checkers, etc. I enter ABC123 first, it asks again. Then I type XYZ123, and it prints access granted and exits. Here's another while loop example that prints only the odd numbers from 1 to 9. We start by setting number equals 0. The loop runs as long as number is less than 10. Inside the loop, we increase the number by 1 each time. Then we check if the number is even using number %2 equals 0. If it is, the continue statement skips the rest of that loop cycle and jumps back to the condition check. That means even numbers are ignored. Only odd numbers reach the print line, so we get the output 1, 3, 5, 7, and 9. Let's build a loop that works like a mini calculator. It keeps asking the user for numbers, adds them to a total, and stops only when the user says done. We start with total equals 0, then use a while true loop so it runs continuously. Inside the loop, we ask for input. If the user types done, we break the loop. If they type something that isn't a number, we show an error and skip that round using continue. But if the input is valid, we convert it to an integer and add it to the total. This gives us a flexible program where the user can enter as many numbers as they want, and the loop will only stop when they're ready. Now let's try it. We enter 2, 4, 6, and 3, then type done. The program adds everything and prints the final total, 15. Now let's build something fun, a countdown timer using a while loop. We start by importing the time module. Then we set a variable called seconds to 5. Now comes the while loop. It runs as long as seconds is greater than 0. Each time the loop runs, we print a message showing how many seconds are left. Next, we pause the program for 1 second using time.sleep. Then we subtract 1 from the seconds variable to move the countdown forward. When the loop ends, we print the final message, time's up. Let's run it. It counts down, 5, 4, 3, 2, 1. And finally, time's up. Let's now build a simple login system with a security feature, a maximum number of attempts. We begin by setting a counter called attempts to 0. Then, we define max attempts, which is how many chances the user will get, in this case, 3. We also set the correct password as Python123. Next comes the while loop. It runs as long as the number of attempts is less than the maximum. Inside the loop, we prompt the user to enter a password. If the input matches the correct password, we display access granted and use break to exit the loop immediately. If the password is wrong, we show wrong password. Then we increase the attempts count by 1, so the user gets closer to the limit. Now, here's the interesting part, the else block that's attached to the while loop. If the loop ends without a successful login, meaning the user failed all their attempts, this else block will run, printing a final message: too many failed attempts, access denied. This structure is very useful in login forms or any kind of system where you want to limit how many tries a user gets. Let's test it. First, we try 3 wrong passwords. After the 3rd try, we get locked out. Now we rerun it, try 1 wrong attempt, and then type the correct password. This time, access is granted. Now let's look at a common use of while loops, finding the first value that meets a condition. We start by setting number equals 1. Then we use an infinite loop with while true. Inside the loop, we check whether the current number is divisible by 7 using the modulus operator. If the condition is true, we print the number and break the loop. If it's false, we simply increase the number by 1 and repeat the check. This approach is useful when you don't know exactly when the condition will be true, and you want to keep searching until it is. When we run the program, it prints, the first multiple of 7 is 7. Let's take a moment to talk about something every programmer runs into eventually, the infinite loop. Here we have a simple countdown x equals 5, and a loop that runs while x is greater than 0. We print the countdown inside the loop, but here's the issue: we forgot to reduce the value of x. That means the condition never changes, x stays 5, and the loop never ends. This is what we call an infinite loop. When we run it, the loop keeps going forever. Now we add the missing line, x minus equals 1. With that in place, the loop counts down properly and finishes. And that wraps up our look at while loops in Python. Practice these patterns, and you'll be ready to build smarter programs. Thanks for watching. See you in the next one.